Hello student, this is a supporting video to help with assignment 1. Assignment 1 deals with vectors, and vectors are dynamic arrays. So why do we need vectors when we already have arrays? Well, if you look at this simple program here in which I have declared an array of integers, and as you can see, this is called numbers. It's got 4 places to store numbers, and the index is going to go from 0 to 3 because we have 4 elements, so the index is going to go from 0 to 3, as you remember from your CISP 360 class. And in each of these, I'm using a for loop to traverse this array, and I'm going to pack the value 66 in each of these. So this is going to go all the way to 3. And when I run this program, I should expect that it's going to display the number 66. And let's see if that is indeed true here. Here we go. So we've got the number 66. The trouble with arrays is that if I would like to add one more element to this vector, then and try to access index position 5, then that's not going to work, because as you can see, when the replit actually does run, it says arrays out of bound. And because I've committed to an array of size 4, in order for us to have more flexibility, we could have, for example, an input file in which we do not know what the size of the input is going to be. We have to bump up our game to vectors. So when you go through this PowerPoint slide, you will see that vectors are very similar in that they're sequential data structures, but the functions used to do exactly the same thing that we do with vectors have quite different names. So our goal during this week is to familiarize ourselves with how to declare a vector, how to populate a vector, how to do all kinds of processing like add elements, remove elements, reverse the vector, sort the vector, and do all kinds of things that we are going to need as we progress through our work in this semester. So what are some other good stuff about vectors is that unlike arrays, we do not need to keep track of index. We don't need to keep track of the size because, as you will see, the size is going to be flexible and dynamic. And we have a standard library, a C++ library, that gives us a whole range of operations to work with vectors. So let's take a look and see how to declare a simple vector. First of all, we are going to need to, I'm just looking for my pen here. We are going to need to include the vector library. So if you do not do this, it's not going to recognize your vector. Remember, we didn't need to do this for arrays, but we need to do this for vectors. And vectors, this belongs to the standard namespace. So we're all just like your standard cout. You're going to always prefix standard whenever we use vectors. So here I've declared an array of a vector of integers, and I've called it numbers. Remember, now here I have not indicated any size, which means my vector has got the capacity to grow. You will read from your book that you can actually give a size, an initial size, and change the size. But just for the simple example, we're just going to presume we don't care. We're just going to be as flexible as possible. This is the way to add an element to the vector. As I mentioned, the library, the functions have got all kinds of names like pushback, add, pop, and this is going to get a little getting used to, in that if this was an array of numbers, I would just say numbers I, or numbers 0. And this is the indexing way. The vector way is to use the name of the vector and to use a dot notation and then use the function that does the work for us. So pushback adds an element. So we're saying pushback the number 2 into the first position, which is our position 0. So in the end, it's going to look a lot like an array in that at position 0, you're going to have 2. Now we say push back 3, which means the next element that's going to get pushed at position 1 is 3. So this is what our vector is going to look like. And in order to access it, we can say what's the number at position 0. So the add function does that for us. And what's at 0 is 2, and it's going to display 2. And remove the last element. Now pop always goes for the last element. So whenever you do a pop, it's going to remove the last element, in which case it's 3. If we did numbers.pop again, this would all remove 2, and then there would be nothing in the vector, right? So there is another method called pop back, and we will talk about it when we go over more code. But know that this is just the basic functions. We can now, does this mean we do not have indexing for a vector? In fact, vectors can have indexing as well. There are two ways to traverse a vector. Either we can use an iterator or we can use indexing. So how can I iterate over a vector? You can very easily do for integer I is equal to 0, I less than, let's say, size of the vector, in which case it's 2, I plus plus, and then you can even do something like numbers I. You can do this. However, it is very, very important to know that because this is a dynamic array at any given size, if the element at numbers I does not exist, you've popped it, you've deleted it, it's not there, then your program is going to crash. So indexing is possible, but it's not advisable. And if you do indexing, then you have to be very, very careful to be sure that that element actually exists. So now let's take a walk and go into this code, which shows us more fancy stuff that's going to be needed in our assignment. So first of all, our assignment has got asks us to create vectors, to create random numbers, to sort a vector, to display a vector, and kind of, take a deep dive into vectors. So here is my main program, which is called main.cpp. I have got my header file exactly the way we did it in our lab, called vector.h, and all my prototypes, function prototypes, are tucked away very neatly into this. Where are all these methods declared? Of course, you know this by now, having done lab 0. All of them are in the vector functions.cpp file. So, but the only thing we have to remember is now we have to remember to include vector.h here in the CPP file. And in the main program, there is no clutter. Our main program is very, very short, as we need it to be for software engineering purposes. All it has is to include vector.h. Please do not include vector.cpp. Your program will not work. Just include the vector.h. Now here, as you can see, I have declared a vector. This is my vector of strings, and that's why I needed this. Looks complicated, but it's a vector of strings. I've got a file here that contains some words that we're going to read from the file into the vector. So here we go. Your assignment actually is far simpler than this. And if you are able to go and if you take some time to go through this tutorial, then you will be very, very well prepared for your assignment. And also this will serve as a revision for your file processing. So I'm opening the file, right? I'm going to call this file variable data. It opens the file words.txt. And what it does is, if it's able to open the file, then till the end of the file, it reads elements from the file into a variable called element of string type, right? I've already declared an element, and push back that word. So let's see how this actually happens. Now, what's going to happen here is if I go into, I've got Apple, boy, quantum, language. So what this is going to do is pick Apple, put it into my words vector. Pick boy, put it into the vector. So ultimately, by the time this loop is done, we have got, as you can see when I've run this, Apple, boy, quantum, language, syntax, and program is into my vector called words. And this is how to do it. So we are here reading from the file into the vector, right? Now we are display the contents of the vector, reverse the vector, display the last word of the vector, and then erase certain words from the vector, resize the vector, and every single time we do an operation, you will see that I have actually chosen to display it. So let's see what happens here. Now, what happens here is, let's run this program. What is it doing? You see, the first thing that it has done is that it has displayed all the words that we picked up from the file and put into the vector. So apple, boy, quantum, language, syntax, and program is here. The next thing that I've done is I have reversed the vector and displayed the last word. When I reverse the vector, program is going to come first and apple is going to come last. And therefore, the last word was apple. Then what I'm going to do is I'm going to erase from the vector words starting at position 2 and ending at position 4. So 0, 1, 2, 3, 4. So quantum, language, and syntax should be removed, and I should be left with apple, boy, and quantum. So, 1 second. This is 0, 1, 2, 3, 4, 5. So from 2 to 4, so quantum, language, and syntax are going to be 0, 1, 2, 3, 4, 5. So, all right. So 2, 3, and 4. I'm sorry. So from here, let me just highlight that. This is actually, now it's a 0. This is a 1. This is a 2. This is a 3. This is a 4 and a 5. So when we do erase from 2 to 4, so this is going to go, this is going to go, and this is going to go. And we should have program, syntax, and apple left behind. And that's exactly what happens here. So now once we're done with that, I have chosen to resize this vector to size 10. This had 6 elements, and then I removed 3. So now what I'm going to do is I'm going to increase the size of the vector to 10 and fill all of those empty spots with XXX. So here, this is what my vector now looks like. I've removed some words and I've added these placeholders. And I have displayed it. Now I would like to sort from the beginning of the vector to the end of the vector. And here is how I say this: from vector.begin to vector.end, sort it. I can actually sort stuff in the middle, but I've chosen to do it from the beginning to the end. When I do that, what happens is XXX lexicographically comes first, and then apple and program and syntax are pushed back. Right? Remember, it sorts in the uppercase first, so all the X's have gone here. Then I display it. Then what I do is I randomly display an element of the vector, and I've created a random number, and that random number has picked the number 1, and the word at position 1 is XXX. I empty the vector and display it, which means now the vector has come to 0. I would like to take a few minutes to go through the functions. How do you display the vector? You can display the vector by using, as you can see, the size function, which tells you how many elements are there in the vector currently. So I is equal to 0, I less than words.size, I plus plus. How did my words come into the function? If you look at the method header, you will see that I have actually passed the vector as a parameter, and so therefore I'm able to access it inside. I've passed by value here, but it would be very wise to always pass by ref, and most of the times you will see that I've used ref parameter passing here. And so now I'm displaying the words at that position, at that particular position. There are many ways in which we can traverse the vector using a for loop, using array-like indexing access, using an iterator. An iterator is nothing but a pointer that you can set to the beginning of the vector, and you can increment it just like a regular pointer to the end. If you make a copy of this, and on your own IDE, if you experiment with this, you will see that all of these give the exact same output. How to empty the vector? Here we've got a words.empty. This function empties the vector, right? I'm sorry, words. Pop back empties the vector, but dot empty is a Boolean that tells you whether the vector is empty or not. All right, and then here, how to erase from the vector? We actually have a method called erase, which takes a beginning pointer and an end pointer, and it erases everything from the beginning to the end. So I've set the pointer to the beginning of the end of the vector, and I've said, well, I would like to start at that position. So iter actually points to the beginning of the vector. Let's say it points here, and I would like to start from the third position. So what I do is I add +3 here. So that's why I'm doing +3. So I now say start erasing from here. 0 + 3 is 3. And then go to all the way to the end to finish +1. Let's say I have to go, I would like to delete 2. So therefore, I'm going to go all the way to 5. But I'm going to add, how many am I going to add here? Iter plus finish is going to be 5. So I'm going to go up to 4 here, because the reason why I need to do finish -1 is you have to be careful that it actually deletes, there is a one-off adjustment that you need to make. And this way you can be sure that it only deletes 2 and not 3 elements. Reversing the vector. You can reverse the vector by just using the reverse function. Know that this one, strangely enough, doesn't have words.reverse, but it actually is just simply a reverse. And this is the method that requires you to include algorithm, which is there at the beginning.